Pointers as function parameters. A pointer can be a parameter, and it works like a reference variable to allow change to an argument from within the function. What it requires as far as the syntax goes is that you need to have a star on the parameter in the prototype and the heading. So if this were a function prototype for a getNum function, and we want to pass a memory address to the function that would hold a memory address to an integer, this is what it could look like. And then in the body of this function, we would have to dereference the pointer in order to access the original argument. Whenever we call this function, we would need to make sure that we're sending a memory address. This shows a program example of sending memory addresses to a function, and what this function is going to do is actually swap the contents in two variables. So in the main function, we have num1, which holds 2, and num2, which holds -3. We send the memory addresses of num1 and num2 to this function, and the function, the parameter, is x, which is a pointer, and y, which is a pointer. So now x contains the memory address of num1, and y contains the memory address of num2. In this function, we also created a local variable temp, and we're going to initialize temp to hold the value that x is pointing to because we're dereferencing x. So temp is going to hold 2. Then on the next line, we're going to put the value that y is pointing to and place it in the variable that x is pointing to. So the value that y is pointing to is -3, and we're going to place it in the variable that x is pointing to. So that will put a -3 inside of num1. Then this last line in the swap function is going to take the contents of temp, which is a 2, and place it in the variable y is pointing to. So y is going, or sorry, num2 is going to change to 2. And we have now successfully swapped the values in these two variables. I'm going to show you a couple of examples where it is the correct way to use pointers and functions. And then I'm going to show you one more example that contains a logic error. So we're looking for pointer function 1. Pointer function 1 has two function prototypes, getNumber and doubleValue, and we can see that we are sending a memory address to both of these functions because they contain a pointer parameter. In the main function, I have number, which isn't initialized to anything. Then I'm going to send the memory address of number down to getNumber. The getNumber function is going to create a pointer called input. This is our parameter, and input is pointing to number. Then we ask the user enter an integer number, and we have to dereference input so that it's actually going to place the value that the user enters inside of what input is pointing to, which is number. So let's just say the user enters a 4. Then this function ends, which means that input, that local variable, goes away. And we are now back up to main, where we called getNumber, and we go down to line 24, and we call doubleNumber, sending the memory address of number. We are now in doubleValue, And double value has a pointer variable as a parameter that now points to number. And then we take the value that val is pointing to, which is 4, multiply that times 2, so that's 8, and placing it back into the variable that val is pointing to. So that's going to place an 8 back inside of number. Then this function ends, which means val goes away. We're back up to main, and on line 27, it's going to print out that value doubled is, and it's going to print out 8, assuming that the user had placed a 4 in the number initially. Okay, we can run this program. G++ pointer function _1.cpp. It compiled, now running it, enter an integer number. So I'm currently in the getNumber function. I'm going to enter 4. Then in the double value function, it doubled it to 8, and then we print it out on line 27. So this is an alternative way to write this program instead of using reference variables. Okay, let's look at pointer function 2. Pointer function 2 shows an example of sending an array to a function and sending it in pointer notation instead of array notation. So what you're used to seeing is this right here where we have the data type and then the array brackets, but instead we're going to put the star there. So this is passing a double array and the size of the array to get cells, and the same thing to total cells. So I create this array which has 4 elements, and then I call the getCells function sending the name of the array and the size of the array. This function call statement is exactly the same as if we were passing the variable or the array using array notation instead of pointer notation. Function call statement has no different syntax whatsoever. But it's in the actual, let's see, getCells. It's in the actual function header and function prototype that we change this. So instead of saying double ARR and then the square brackets, we have a pointer there instead. And then if we want to use pointer notation to actually access the array elements, we can do that. So remember, this is the same thing as saying count sub ARR using those square brackets, but instead we're using pointer notation. Same thing for total cells. We're using pointer notation there as well. Okay, I'm not going to run that one, but you have access and you can run it if you want to. I'm now going to show you pointer 3. And remember, this is an example that is not a good example. And I really do want to draw this one out so I can explain why this would cause a problem. Okay, we have a getAnimals function, a printAnimals, a sortStrings function. Notice that getAnimals is returning a pointer to a string. It's returning a memory address. And printAnimals and sortStrings is we're sending a memory address to those. In the main function, I create a pointer. So let's go ahead and draw that pointer. This pointer is allowed to point to a string, and it's called animals ARR PTR. And then I call the getAnimals function, and I don't send anything to that function. Okay, so let's go down to the getAnimals function. I'm going to make the code a little bit smaller. And actually, let's do this right here. And the code is too small now. Okay, there we go. So here's our getAnimals function, which returns a memory address. And on line 38, I created an array. So here's my array. The size, I forgot what size is up at the top. It's 5. Okay, so this is a 5-element array. And the name of the array is animals array. And then on lines 40 through 44, I have a for loop that allows the user to enter in the animal, and it's a string that we're reading in, and it's reading it into the array using pointer notation. So far, all of this is totally fine. So the user will enter in these different names of arrays like dog, or names of animals, cat, rat, horse, cow. Perfect. Now on line 45, we have an inline, and then we return animals array. Okay, so animals array holds the starting memory address of this array. And so let's just make up a starting memory address. 4A00 would be the starting memory address here. Okay, so that gets returned back to animals array pointer. So we will correctly have 4A00 returned back, and that's the pointer. In other words, how I usually draw it is I do this right here, right? But remember, any local variables created in a function go away when that function ends. So whenever this function ends, this animals array, which was created in this function, also goes away, and we no longer have access to that array. We have the memory address of where that array used to be, but it's no longer there because it was a local variable. To prevent this, you'll have to do dynamic memory allocation, which I'm going to show you in a future video. But for right now, just know that this is the problem with creating this array locally and then trying to return the memory address. That array no longer exists.